Welcome to video number 3 of this presentation. I have those same two frequencies, 528 and 1584, that I used in the previous video, but there's a difference. This time the second channel on the scope representing a second winding on the coil, will be slightly out of phase. And this will demonstrate when the two waves are in perfect harmony with one another in phase, that we'll get maximum magnetic field strength or detect maximum magnetic wave strength on the meter. And when the two waves are opposite one another and they sum up to 0, and you'll be able to see this on the scope, the magnetic field goes down to 0. You get nothing out of there. And the reason why I want to show this is that in the next video I'm going to demonstrate standing waves. And when standing waves are in phase with one another, you will get maximum field strength. When standing waves are opposing one another, the two fields that make up the coil are opposing one another, you will get no magnetic field, but you will get a current flow and you will have energy produced. And this is supposed to be the scalar wave. And I'm going to say supposed to because I can't measure the scalar wave, but I can prove that we're providing current and energy to the coil. But you can't see any magnetic flux come out. Rather interesting phenomena. So here we go. Start the program, and here you go. You have the second channel slightly out of phase with the first channel, and watch the needle on the meter. When the two humps are aligned with one another, perfectly aligned, the meter's at maximum, and when the two valleys are perfectly aligned, the meter dips. Now I'll show you what this looks like when the waves are combined. I just switched frequency. Here we go back to the lower frequency. So the waves are combined, and you can see that maximum, the two waves combined, they add together. Now they're opposing one another, come down to 0. Now they're going to add together. They're opposing one another, add together, and we're going to switch to the other frequency. So they're adding in to the point when they're in phase, they create a larger wave pattern. When they're out of phase, and they're perfectly out of phase, 180 degrees out of phase, they create a zero wavelength. And I'll demonstrate that by taking the phase lock out. So I'm going to stop that program, and I'm going to get rid of the phase lock. I call it a phase lock because what I really meant is a little offset. I'm going to change that back to 0. And now I'll be able to show you the in phase and out of phase wave patterns. We've already seen the in phase, but I'll just duplicate that by doing a start. Okay, so the two wave patterns are in phase. The two humps line up with one another, if you look at the scope, and the two valleys line up with one another, and the meter is, you know, it's measuring the magnetic field. We'll switch frequency, and the higher frequency, the humps are lined up with one another, the valleys are lined up with one another. And because we're slightly higher frequency, we get a little bit more magnetic field out of there. I'm going to stop the program, and I'm going to this time do an invert sync. In an invert sync, start the program, and start. Okay, Spooky is reinitializing itself. Takes a few seconds. Boom. There you go. Now notice The two humps are completely opposite one another, and the two valleys are matching, and there's no magnetic field being produced. So what I have showed you just now is that they're 180 degrees out of phase, yet we're generating waves, but they're 180 degrees out of phase, and they sum up to a little ripple. That would be a very straight line if I went slower. What's happening is that the scope's not responding to the lower frequency. It's a very little ripple, almost a straight line. And you can see the meter showing you hardly any magnetic field whatsoever. All right. So this is a short presentation also. I'm going to now try to demonstrate what I am calling scalar waves and how you generate them, and try to prove to you that we're actually generating some energy, like a scalar wave energy. That'll be video number 4.